Welcome back to Science Sundays. Today we're exploring the properties of substances by making our own lava lamps at home. This is a lesson in chemistry for students as young as 2nd grade. Check it out.
So before we get started today, your at-home materials, you're going to need some vegetable oil, corn oil. I haven't tried olive oil, but it probably works as well. You want some water. You need a clear, a tall container. So for example, I'm just using a large jar, but you can also use a water bottle, which is pretty easy. Need some food coloring and some Alka-Seltzer tablets. So what we're going to be looking at is we have our jar and we have our water. And so what we want to do is we don't want to fill up the jar all the way. So the water is about less than half. Okay, we don't have any precise measurements because it all depends on your container that you're using. So you want just less than half. And you want to add, you're going to add oil, and you're going to add about the same amount in your jar. And so before we get into those pieces, we definitely want to ask students, what are you noticing and what do you wonder as I pour the oil into the water? And so we are going to go ahead and do that. And so they can definitely see that something's going on here. And we also definitely see some separation. And as we get into the older grades, we are definitely going to get into density and what's going on with density inside of our container. So then what we do is we want to add food coloring. You can use any type of food coloring you'd want. And if you look at it, we can see dots and then what's going on there. So we see something's going on with that red food coloring right in the middle. And why did it go to the middle? I wonder why it did that. So there's definitely a lot of inquiry questions that we can ask students about this experiment. All right, so now what we're doing is we are going to add an Alka-Seltzer tablet. So we know that when you add this to water, what happens? You know, and you can show it with just water. So if I add this to this piece, is it going to float like the food coloring? Is it going to sink all the way to the bottom? And then what's going to happen with it? So you can either use a full tablet or a half tablet. I, with a class, like to use a half tablet because you'll see with the chemical reaction that's going to happen that I can have twice as much fun instead of just one time. So it kind of extends the experiment a little bit longer. But let's see what happens. So we're going to take our half of our Alka-Seltzer and drop it in. And then you can kind of see what's going on. So our Alka-Seltzer tablet is down at the bottom. Our red food coloring bubble popped. But then you notice what's going on here, okay, within our oil. And so when we go over chemical and physical properties or changes, we like to talk about is, can we actually get that Alka-Seltzer back to being what it normally was? And obviously the answer is no. So that's going to be definitely a chemical change because the chemical properties of the Alka-Seltzer have changed. But if you notice, it starts to slow down. So after a couple minutes, after students have written down their observations and looked at how the molecules are moving, I'll say, all right, drop another one in. And then we get to see even more happen. Students love this.
Head over to our website, turnto23.com/Science Sundays, where Jamie has a full 10-minute episode explaining more of the science behind this experiment, and she explores some of the extensions teachers and homeschooling parents can offer to their 2nd, 5th, and middle school students. And make sure to join us next week on the 4th of July as we talk about the science of fireworks and the chemistry behind those colors you'll see in the sky. Have a great week.